So now that we have all of our images annotated, we are going to add the three that we just did to our data set. When we add images, I recommend annotating all of them, making sure that each of the projects that you are assigning to others or the tasks that you're assigning to yourself are done before adding. But in the event that you want to annotate and add as you go, ignoring whether the data set is completely annotated, we can add them using these proportions and percentages. Now, what Roboflow is doing is it's organizing our data set into three categories: training data for the machine, validation data to ensure the machine is assessing correctly, and a test set so that we can see what our machine looks like in real time. We can change what we want to add to what. So perhaps you want to just add all of your images to a training data set and just train. I would recommend definitely splitting between what Roboflow has already distinguished, which is train, validation, and test. This will ensure not only that we're training our data set correctly, but it's being validated and tested as if it were used in the real world, which after all, that's the point of doing damage assessment with machine learning. I'm going to keep these proportions between 70, 20, and 10%. If you, for some reason, want to add 75 to 15%, definitely be careful proportions. You want to make sure everything is balanced. So I'm going to add our three annotated images. I've already annotated over 800 images previously, as you can see, just a day or two ago. So jumping into how do we get to that final step in Roboflow? Well, we have our annotations kind of on deck, but we also have about over 800 already added to the data set. So let's just jump to see what the data set looks like. Here is where you can evaluate all of the photos that you've annotated and your team has annotated according to what is damaged, whether that be according to FEMA's guidelines or your own local guidelines. So we can see our training data set, our validation data set or sub data set, and our testing set. Now you might be wondering, like, what information am I trying to get from this? Well, using Roboflow's health check, we can actually see some more descriptions about the data, and that can include the balances in each category. That means how many photos are evaluated as major, how many photos are evaluated as affected, and the differences between these is super important. Giving a machine learning algorithm the ability to understand between these types of categories is heavily dependent on how much information you're feeding it. It's like if you were feeding a machine learning algorithm images of apples and only one of them is of an orange. Now, it's going to overinflate images based on what it's learned, and that is images of apples. So in this case, we see from this health check that there's not really a lot of destroyed homes, and that could cause major issues in our machine learning process. So I recommend we continue forward to see what would actually be produced, if we were able to balance these out, and also recognizing that damage is occurring as it occurs. It's hard to collect based on each category. In fact, it almost relates to confirmation bias. So by using maybe other data sets, don't just use your locality. Use a breadth of different images and a breadth of different data sets to really try to balance these out. So we can also see from the health check the average size of a photo. That's important because you want to collect similar sized photos. And what that'll do is proportionally, the machine will learn how large an apple is, how large a home is. Here we have quite large photos, which is okay, and we'll continue on. And we even can see here, we have very wide photos. When you think about landscape photos and from a street view, we can start to see some similarities between the images. This will all affect how we machine learn. So let's jump back to our data set. I think we are just about ready to generate our first dataset version.